Thanks for joining us this morning on this webinar on using Modbus TCP in a tag-based environment. The presentation itself is roughly about 18 minutes or so, and if you have any questions, feel free to put them into the questions panel and we'll get to them at the end. So with that, let's get going.
Welcome to today's tutorial. Let's get started. Let's have a look at our agenda for today. Today, we're looking at using Modbus TCP in a tag-based or variable-based environment. In Cscape, we call that variable-based advanced ladder. So whether I say variable-based or tag-based, we're talking about the same thing. First, we'll do a quick review of Modbus. We'll talk about the Modbus data model, and then we'll look at the challenges when you're using a variable-based or tag-based environment with Modbus, which is more of a register or memory-based protocol. Then we'll go through some specific strategies for implementing Modbus, whether you're using Modbus TCP as a server or slave, or you're using Modbus TCP client or master. We'll have demonstrations throughout, and as always, we'll finish with the Q&A session. First, let's do a quick review of Modbus. Modbus is the most common industrial protocol that allows multiple manufacturers' products to talk to each other. Modbus is supplied in a few different ways. Traditionally, it started out as a serial protocol, and it's still widely used in that way today, typically over RS-485 multidrop, using a form of Modbus called Modbus RTU, which is a master-slave protocol. The most common way of integrating Modbus is over Ethernet using something called Modbus TCP. Modbus UDP also exists, but it's not as common as Modbus TCP. Next, let's look at the Modbus data model. Modbus was modeled around traditional PLCs where all the data was Boolean or integer based. In terms of register addresses, Modbus is a 1-based protocol. Over on the right, you can see a list of the 4 different types of Modbus data, as well as their addresses. As you can see, each section of data starts with a 1 as opposed to a 0. The original Modbus address scheme, which is most common today, is 5 digits long. There is also a 6-digit scheme that exists, which is not as common. So what are the challenges with using variables or tags in your PLC programming when using Modbus? The first challenge is Modbus is register based, while modern PLCs are variable based. Modbus is also designed purely around integer and Boolean data. 32-bit floating point values can be represented by taking two 16-bit Modbus words and concatenating them together. However, manufacturers are not always consistent with their word order, so you need to be careful to ensure that you receive both halves of that 32-bit data simultaneously. Next, let's talk about a method using variable-based advanced ladder in Cscape for applying an OCS controller as a Modbus slave or a Modbus server. As an OEM or machine builder, I want to supply my equipment so that the important data that resides in my machine can be accessed by my user, such as status, commands, and setpoints. In this application, we want to create a published Modbus data map to make key data available to almost any system they are using, whether that be a SCADA package or a historian, for example. Modbus is great for this as it's the most common protocol, and so it can interface to many different manufacturers' products. In Cscape with variable-based advanced ladder, traditional memory addresses and register addresses still exist in the OCS. They're just in the background. So with the OCS, since it does have a memory infrastructure, there already exists a fixed map between the OCS register space and the Modbus register space, which is shown on the chart on the right. Note that the 4 different types of Modbus variables, Modbus coils or outputs, Modbus inputs, Modbus analog inputs, and Modbus holding registers are all mapped to different types of memory addresses of the OCS. So in your application, you'll be taking those variables that you want to make available over Modbus, and you'll use the variable editing tool in Cscape to map those registers to specific OCS register locations, which will make them available on specific Modbus memory locations. So let's look at creating your Modbus data map. So for any real-world I/O that you want to expose to your customers, you don't have to do anything, as that data map is fixed. For I's, Q's, AI's, and AQ's, all that real-world I/O is pre-mapped as you can see in this table. The only configuration required is to check a checkbox saying you want your product to support Modbus as a slave or server. However, when exposing other variables, then we need to go to the trouble of creating those variables and mapping them to specific memory locations in the OCS. Here we recommend that you keep it simple and only use two of the Modbus data types: the holding registers, which are word length registers, and the output coils, which are read-write Boolean type memory addresses. I would also recommend that when you're mapping those variables, start at R1 for your word type and longer variables, and then start at M1 for your bit type variables. That will get them mapped over to Modbus 43001 for holding registers and Modbus 3001 for the output coils. If you're concerned about the data being read-only in your equipment and then being overwritten from the outside, you can use logic to prevent that from happening. For instance, if you have a boolean that you don't want to be overwritten by Modbus, if you just use it as a coil in your application and your logic program, then Modbus can't override it because the OCS logic is continuously writing that coil. Similarly, with an integer or longer type value, if you want that to be read-only and you don't want that to be overwritten, then by using a move function or another function that's continuously writing that value in your program, it'll prevent Modbus from overwriting it. By doing that, you'll eliminate a need to use input registers or input bits. For 32-bit data types, you just map the 32-bit variable to an OR register. Remember, we're using OR registers when we map two word and longer type references, so it'll occupy two of them consecutively. Then, when you're publishing your data in your machine documentation, you're going to publish the first Modbus reference for that 32-bit value, the data type, whether it's double integer or real, and then you can indicate that it's data that has a Modbus length of 2 words, because the Modbus spec says that all length must be specified in words. You can see an example of that map in the bottom right of the slide. Then, when a read-write Modbus command is received, the OCS will properly react when the first Modbus address is referenced with a length of 2, and it will return the proper value. Next, let's look at performing the mapping itself. So how do I take my variable that I just created and map that to a specific OCS memory location? Normally, I don't need to worry about that if all I'm doing is creating internal variables. To do our mapping, we use the program variable editor. In the memory column, you can simply type in the address that you want to map that variable to. In the example on the right, you can see the first reference is for a variable called machine mode, which is an unsigned integer mapped to R1. R1, as mentioned earlier, is mapped as Modbus address 43001. Anyone who is reading or writing that data externally over Modbus would use the address 43001. The OCS would then use the data that's stored in R1, and that data is tied to the machine mode variable. Let's begin a demo where we'll look at a program for an XL4 that has been designed for applying Modbus as a slave or server. So I'll open my XL4 program in Cscape. I'll go into hardware configuration. We need to do that from Ethernet, so I'll go into LAN 1 config. Your Ethernet must be fully configured here with a valid IP address and netmask. Then under resident protocols, you need to select Modbus slave. From a configuration standpoint, it's very straightforward. Just make sure Modbus TCP is selected, and there's the default port. And then we're configured on the network side. Next, we take the variables that we wanted to expose or publish with Modbus addresses and map those using the memory column in the program variable editor. So here I have this machine mode variable, I have product select and volume select. These are all integer based variables, so I've mapped them in consecutive areas in OCS memory to make it efficient as possible for the external device to grab the data in as few messages as possible. For example, in this application, I only have 5 words mapped to Rs, which are available as holding registers. With these, a single Modbus holding register read with a length of 5 words could be used to read all that data in one go. For Booleans, I have a few variables mapped into Ms. If the outside device were to read 2 consecutive coils, then they could get all the data here as well. That's all we need to do when applying a Modbus slave or Modbus server to an OCS product. Next, we'll look at using tag or variable based logic to apply an OCS as a Modbus master or client. Here we want to read and write Modbus data from a third-party device into variables in the OCS program. So let's look at that process. The first step is to create a series of arrays for reading and writing the different Modbus variable types. With Modbus coils, you could create an array called Modbus_coils, for example. If you had 100 or so coils that you need to read or write, you could put a dimension of 100 for that array. Similarly, if you're reading input bits, you would create an array called Modbus inputs, and you would do the same for input registers and holding registers. Again, select the correct type for each of those. Coils and inputs are Boolean types, while input registers and holding registers are integer types. Then you would map each of those arrays to a convenient area of your M or R registers. For example, here I mapped the coil starting at M101. I mapped the input starting at M201. Then I mapped my input registers starting at R101 and my holding registers starting at R201. That'll make it easy for me to correlate which piece of Modbus data is going to be mapped to what variable. The third step is to configure the OCS as a Modbus master or client and then use those arrays you just created as the local variables when you're reading or writing to Modbus address space to that third-party device. The final step is to go back to your variable editor, add in whatever variables you're using in your program that you want to have tied to that Modbus data, and then map it into the register location that corresponds to the appropriate Modbus array member. Now let's begin our demonstration where we'll apply Modbus as a client or master. In this example, we'll configure and program an OCS to interface with a motor drive that has a Modbus data map as seen on the right. In this example, we'll just be working with the holding registers, however it's the same process if you're working with the other data types. We'll create retained variables that are tied to the appropriate Modbus registers for commanding motor speed, acceleration and deceleration, and for monitoring actual speed, current and torque. So first I'll open Cscape. Here is our program which is configured for an XL4. The first step was to create that array that we can use for reading and writing the holding registers. So for this I'll go to the variable editor. For all our Modbus registers, we'll do all our variable mapping and building of our arrays in the retain variables section. So I'll add a variable. I'll call this Modbus hold reg for my holding registers. I'll make it an integer type and I'll give it a dimension of 100. That means I could read or write up to 100 holding registers using this array. Then I'll map that to a convenient location, so for example R1001. If I had other Modbus types, I'd put in additional arrays here as well. Next, I'll go to the hardware configuration. I'll make sure under LAN1 config that I'm configured for Ethernet, because that must be configured properly. Then, from this list, I'll select Modbus client. Then I'll go into my network configuration, and here I'll leave it all at the defaults, except I'll assign a status register here. And I'll call that Modbus client status. That's 4 consecutive 32-bit words. Then I'll go in here and configure that as a double integer with a dimension of 4, because as I mentioned, there's 4 consecutive 32-bit words. I'll make sure I don't forget to add my index since it's an array. That's my top level configuration complete. On a device level, this is where I need to add the device as well as its IP address. First, I'll name this device, and I'll name it drive. Then I need to input my target IP address. This could be a variable, but I'll just hard code it in this case. Let's say that's the address. I can leave the Modbus port the same. Here we can configure the style of addressing that the slave or server that we're talking to in our fictional drive uses. It uses the traditional 5-digit Modbus addressing. Here we can also enable status for our server. I'll leave that for now, but it's just 2 16-bit variables. So I've configured the network and the device side of things. So now let's go into the scan list. First, we have the device that we're working with, which is the drive device that we configured. Next, we have the device register, so where do we want to grab the data from? There are multiple ways that you can approach this. For this, we'll look at our data map again. So we have 9 different pieces of data that are available to us, which are all in a row. One approach would be to have a different entry in our scan list for every variable and have several different reads and writes to grab this data. That, of course, is not very efficient as we have to send many messages over the network. However, since our data is all consecutive, another way we could do it is just to do a single entry in the scan list and read/write it all simultaneously in one message, which is much more efficient. So let's go about that approach instead. So our data is starting at Modbus 40001 up to Modbus 40011. The last three variables are real values, which take up 2 consecutive words. So our overall length here to read all this information is actually 12 words. So back in Cscape, we'll set the device register to 40001 and the length to 12. Then here, under local, is where we use our Modbus array. That's Modbus holding register, and we'll start at index 0. All 12 of those words will be contained in this array of data, which is 100 long. I'll change my update type to polled read/write. Those words will be read, and if they change on the OCS side, they'll be written as needed. And for this example, that is our second step complete. The last step is to add some of these variables to our program. We can take our variables from our Modbus holding registers and give it a more meaningful name instead of just referencing the index. So let's start with the first variable, which is the frequency command, which is at the very beginning of the array. So in Cscape, I'll go back to my retain area of variables, I'll insert a variable, and I'll just call it frequency command. That is an integer, and then I'll map it to the same location in the array. So again, my array starts at R1001 and has 100 elements. So the first element in the array is where my frequency command is, so I'll map it as R1001. Next, let's say the next bit of data that we're interested in is actual frequency, which is Modbus register 40004. So that's located in the fourth element of the array. So I'll add another variable which I'll call frequency actual. Again, this is an integer. So I need to map this to R1004, which is the fourth entry in our array. Finally, let's do a 32-bit variable. So looking back at our data map, let's say I also want motor current, which is a real number that's mapped at 40,007. So at the 7th word in the array, that data starts. So in Cscape, we'll add another variable that I'll call motor current. This is real or floating point data, so I need to assign it as real. Then I need to map it to the right location in the array. It starts at the 7th word, so I'll map it to R1007 in this case. So that's our demonstration of setting up Modbus as a client or master complete. Thank you for joining us for today's tutorial, and the Q&A session will begin shortly.
Okay, nice and straightforward one for you this morning. Not seeing anything coming in as yet. So following on from that, we do have another video regarding tag-based with creating and editing. And that's following up by using IEC again into security and then a bootloader recovery tool, which will take us to mid-10 July. Failing any more questions, thank you all for joining us this morning, and we hope to see you again next week.